Alright, we're going to start with number 3 here. We have this cannon that shall go straight upwards. A certain time after launch, it's moving upwards with this speed. So, if it's moving upwards with that speed 2.2 seconds after launch, do we assume that its original speed was higher or lower? I'm going to assume that it was higher, right? And that because because the cannonball, so this is number 3, the cannonball is in free fall. Therefore, the acceleration is little g downwards. Downwards. And so is slowing on the way up. So the cannonball is slowing down on the way up. What does it have to do to turn around at the top? It's got to stop for a second, for a millisecond, and then it will come back down. So I'm going to assume that this 2.2 seconds is before that turnaround. Might be, might not be. And then we'll see where the 5.1 falls. So let's see, it's downward, slowing. We know that it's straight up. Good, that's all I need for my Y. Any questions on the Y before we jump into the how? Okay. So in the how, I'm going to grab an equation here. And the equation, it talks about my velocity is changing because I'm accelerating for a certain amount of time, is this one. V final is V initial plus AT. And so I'm going to do this in case A, which is going to tell me that the V final in this case is how fast it tells me it's going, 17 meters per second. Its V initial, I don't know what that was, because I don't know what speed it was launched at. Plus, I said in my Y, it's accelerating downwards at little g, so downwards, I'm going to assume up is positive, down is negative. 9.80 meters per second squared, and it's been traveling at this point for 2.2 seconds. And grab my calculator. I get 38.6 for my V initial. Meters per second. And since it's positive, I know that that is upward. That makes sense to me. Yes, no. All right. Moving to part B. Now, we could do part B either from the very beginning or how much it's changed as it's gone from 2.2 seconds to 5.1 seconds. Which way do you guys want to do it? From the very beginning or from the 2.2 second part? Huh? from the 2.2. That's probably the safer way to do it, because let's say I had messed up this calculation. If I had messed up this calculation and I used that answer of 38.6 meters per second in my next calculation, then I'm going to mess up that one too. But if I start at the 2.2 with numbers that I'm sure of, then I'm good. So in this, using the exact same equation that we just used, okay, we don't know what it ends up at, so that's our V final. Our V initial is where it started, which is our 17 meters per second, plus still negative 9.80 meters per second squared. And now our delta T would be our 5.1 seconds minus our 2.2 seconds. We actually have to do the delta this time because, unlike every other time, we have to, we're actually not starting at a time of 0. And I get a V final of negative 11.42 meters per second. And since they asked for the magnitude rather than the whole velocity, I would report that as 11.4 meters per second. All right, so let's look at number 8 here. A baseball seemed to pass upwards by a window 20 meters above the street with a vertical speed of 16 meters per second. The ball was thrown from the street. That's its initial speed. What's something we know about the ball right away? It's in free fall. The ball is in free fall. So what does that tell us? What's affecting its motion? Little g, gravity, right. So the acceleration is little g in which direction? Up, down, right, left? Down. And let's see if there's anything else we really need in there. What does the ball do at the top? At the top, what do we know about the ball? The ball has top of its path. What do we know about the ball? What about it? Velocity. Excellent. Velocity is 0. All right. Okay. Any questions on that? Why? All right. Go on to the how. I'm going to draw myself a little picture so I can better handle this. We got our building. Here's our window. And they said that window is 20 meters up. Where do you guys want to call? Where do you guys want to call height of 0 or position 0? Where do you want to call position 0? The ground, okay. Which direction do you guys want to call positive? Up, okay. And let's see what else they tell us. They tell us the ball goes up, some height, back down. As it passes here, they tell us that it's going at 16 meters per second. Ooh, how fast would it be coming back down past the window? Negative 16 meters per second. Right? Same magnitude, but on the way down, because it's going to have just as much time to go up as it is to come back down to that point. It's under the same acceleration. So it's going to be going the same speed, just in the opposite direction. And they ask us, what's its initial speed? Well, let's think about the things we know about it. We know that its initial speed would have to be upwards. We know that it's gone 20 meters and is now going 16 meters per second. And we know that during this whole thing, it's accelerating downwards at little g because it's in free fall. And so we look at our equation and say, which one tells me a lot about speed or velocity changing because I was accelerating and I went a certain distance? Well, that one would be this one right here, for hopefully obvious reasons. So that's the one we're going to start with for part A here. And now I'm putting in the things I know. It ends up going 16 meters per second. It started at I don't know what. I know acceleration is negative 9.80 meters per second squared. Its change in displacement is positive 20 meters up. And that ends up being, let's see, 25.5 meters per second. So that's its initial upwards velocity. Any questions on that? Nope. All right. For part B, I'm looking for its height, altitude it reaches. I know that its velocity is going to be 0 up there at the top. You guys help me put that into the y. I'm going to stick with my same equation. I know it's 0 meters per second. Its initial velocity, I'm going to use it from when it started on the ground. Squared plus 2 minus 9.80 meters per second squared. Still accelerating. And I don't know how high it's going to go. I'm going to call that h though. And so that'll be the height that it goes from, it ends up going down to 0. And I got 33.1 meters as my height. Any questions on that one? All right, let's move on to part C. How long after it was thrown did it pass the window? So now, rather than displacement, I still know a lot about the initial velocity now, and I know about the final velocity, and I know it's accelerating, but they want to know how long it was accelerating. And so I'm going to grab this one right here. And so for part C, they wanted to know how long after it was thrown did it pass the window. So I know at the window it was going at 16 meters per second. It started at my 25.5 meters. 25.5 meters per second, accelerating at negative 9.80 meters per second squared for some amount of time. I'm assuming that my time started when it was thrown. And I get an answer, if I do that out, of delta t should equal 0.965 seconds. on part C there. All right, let's go on to part D then. In part D, after how many more seconds does it reach the street again? So really what they're asking for us to look at in part D, if I go back up to my diagram, what I'm looking at here is this from here around using just, they're asking the green part of the path. I just figured out this part. Now I can do this as segments. I can say, well, I know that as long as it took to get up to the window, it's going to take to get this last leg from the window down, it's going to take that exact same amount of time. I know that it takes the same amount of time to go up to the peak from the window as it would to come down to the peak, from the peak down to the window. So I could break this up into 4 segments and then add up 3 of those and end up with my answer. Or I could do it all in one fell swoop by using, and the last of my kinematics equations that I haven't used in this one yet is this one here. And by using this one, remember this one is where I end up, is where I started, and how far I went because I was moving when I started, and how far I went because I was accelerating during that time. So in this one, we're looking at just that green part of the path that I highlighted a second ago. I'm going to end up down at 0 meters. I'm going to start at 20 meters. My initial velocity is 16 meters per second. That should be positive because it's upwards. Don't know my time. Plus 1/2 minus 9.80 meters per second squared. And delta t squared. And I solved that for t. And kind of got squished there. Let's see if I can. Better t squared there. T squared. Solve that and I get 4.23 seconds. Would you like me also to do it the segmented way? No? All right. We're good on that problem then.